Hello everyone. Today you will learn what is stress concentration and what is the relationship between mesh element size and the stress concentration factor and how stress concentration is important for ductile as well as brittle materials. You will also learn how we can make a copy of a simulation study. So let's start our journey now. So first of all, make a sketch like this. This is a sketch of a 1/4 of a plate with square hole because we are going to carry out a symmetric model simulations of a plate with center square hole. So make this sketch on the front plane and exit from sketch and just make simple extrude of depth 10 millimeter. After that, go to the simulation tab and make a new simulation study. Here, we will keep the mesh element size 10 mm. So, we are giving the name to this study 10 mm element size. Okay. So, just apply a material that is alloy steel. Our next step is to apply symmetric boundary conditions on this face as well as on this face. So go to the fixtures and from the fixed geometry go to the advanced options, then select the symmetry boundary conditions, select this face. You can see the preview and also this face. So we are going to apply a symmetric boundary condition on two faces. You can see a full model preview of a plate with center square hole. Okay. Now apply a load of a pressure that is 1 megapascal on this face. Reverse the reactions, change units to megapascal and enter the value that is 1 megapascal. Now go to the mesh and create a mesh. From mesh parameters, set the element size to 10 millimeter. Then create the mesh. Now run your simulation study and wait until your solution converge. So we can see the maximum stress in the extraction, maximum normal stress in extraction is 4.382 megapascal. That is occurring here where these two sharp edges meet. That is 4.382 megapascals. Now again, just make a copy of this study and give it the name that is 8 mm element size. Okay. Now go to the mesh and create a mesh with the element size of 8 millimeter. So mesh element size has been reduced in order to make a more fine mesh. Then run your study. You can see now that the maximum normal stress in extraction has been increased to 4.02 megapascal. And if we go to the previous study, that value was about 4.3 megapascal. So that means with increasing and decreasing the element size of a mesh, the normal stress value has been increased to 5.042 megapascal. The question is that where this value increases. You can see that at the whole part, the stress almost remained same in both studies. But if the change occurs here, where that is the sharp corner, where these two both edges meet with each other without making any radius. So that is the problem of stress concentrations. Again, we make a copy this study and change element size to 5 millimeter. Okay. Again, recreate mesh and change element size to 5 millimeter. Now run your study. So our solution has been completed and now you can see that the new stress is 5.29 megapascal, whereas in previous study that was 5.042 megapascal. The increase in stress occurs in just this here on this sharp edge or sharp corner. So this is the stress due to the stress concentration, and if we decrease the mesh element size more, it can increase and ultimate it can become infinite. So if your material is ductile and loading is static, then there is no point of concern, just you can neglect this stress values. And if your material is brittle and you have a fatigue loading, then you can decide the fatigue life depending upon the or considering the stress values up to somehow. So I hope you enjoyed this tutorial and learn how a stress concentration is linked with a element size of a mesh. So just make a simple radius of the radius 15 millimeter here and make a new simulation study and see the results and give your opinions or results in our comment sections. Thank you for watching.